In this lecture, I am going to refer to NIST a few times. So I wanted to find it first. The NIST is the National Institute of Standard and Technology, and they are classified as a measurements and standard laboratory. They have been around since the very early 1990s, and this takes responsibility for everything from controlling the things like weights and measures. So how much is a kilogram? How long is an inch? All the way through a definition of a bunch of different technologies, standards, things like encryption, and also what cloud is this PDF. The next definition of a cloud computing is often used as a canonical resource for describing precisely, and what cloud is. It's a very short document. So it was created in 2011 and it talks about 5 specific cloud characteristics. So these are first characteristics that NIST talk about on-demand self-service. Now what this saying here is that consumer should have a ability to provision things like server time on network storage as needed, and not only as needed but to do automatically and without requiring human interaction. This way we see that manifest itself in modern cloud. Computing is the thing that you go to the cloud providers portal and you say I would like to a server, or I would like a storage, or I would like a service. So you click some buttons and it automatically provisioned. It may take a few minutes, but there is no human in the other end or plugging in servers or provisional virtual machines. So it happens on the mind and via the self-service. The next characteristic is broad network access, and that's what nesters talk about when here is the capabilities of the cloud and that are available over the network, and you can access them via the standard mechanism such as by the browser or by the mobile app. I can go into a portal such as Amazon's AWS over the internet in my browser and then provide those on-demand self-service resources pooling, and this is a really key characteristics of the cloud in these days. By in that on-premise model, you may have to have a server which does a thing. For example, this is the finance server and it services the finance department and it does purely finance thing. Nobody else uses its resources or any other way. So when we talk about the resource pooling, we are talking about a cloud provider having a physical resources which are used by multiple consumers. You will see often this referred as a multi-tenant model. Now those tenants may all get their own logical units of the piece of a physical machine, but it is the one that underlying physical piece of paper or hardware may be divided up and allocated dynamically to a different consumers, therefore pooling that one resource across different tenants. So you don't usually know as a tenant which other tenants are using that same underlying physical instruction and indeed which cloud is done. So you don't care because you are not paying for the physical infrastructure, you are paying for the logical service and it is delivering it to you. So this is really the key characteristics of a cloud. And it is one of the things that makes good cloud implementation so successful, because they can pool resources which then gives the ability to do things like the rapid elasticity. When there is this underlying resources pool and a client comes along and says yes, I would like more resources now, then that can be provided by the cloud services. Elasticity talks about the ability to either provision more resources or go to the other way of release resources, so that cloud can give and take contact and response to how much the consumer need it. Now that's important because we think back on the premise model. You would have the server and you would pay the server no matter how much of it you use the cloud. So you provision or release what you need, or it may be don't need such you aren't under provision yet, so you are also not paying for excessive resources, which being as the final characteristics measure services, because the amount you are using can actually be measured, then you can be charged accordingly. So I often use the cloud services in a way where I say, hey, I am to do about something where I actually require a lot more, say I would say database power. So I'm going to scale up my database, and I'm going to actually pay 5 times more during this period where I need the extra computing power, and I can do that because I have rapidly in my cloud service, and I'm going to pay it for the write-up until the points. And write decisions to release those resources, and then that rapidly will let me contract, and the amount I will pay will go back down the characteristics of a measured service that can apply to everything from the amount of computing power using to storage through the bandwidth, and certainly different service is different, and cloud provider different cloud provider service will measure differently, but the one common characteristic they have is, according to this definition, is that what you pay, that will depend on how much you use. These 5 characteristics are absolutely fundamental to those way the cloud runs. So the next thing we'll look through is extremely important to understand the infrastructure, platform and software as service that they are going to look. So you very often see these 3 definitions as a cloud service: use IaaS, PaaS and SaaS, infrastructure, platform and software as a service, and I wanted to define each one of these 3. So throughout this, and I am going to give you a number of different Azure examples, but I am going to make sure that I talk about the cloud as much as generic terms, because whether it's a Microsoft or Amazon or Xspace or whoever's, this principles always same. So let me show you how to define this in 3 models. So, and in fact we will start by looking at the very old way to doing things, like the on-premise model. So let's think about everything that you actually have to manage in an on-premise data center. Everything from the networking through the storage, obviously the server themselves, if you are using any virtualization, and then the operating system, the middleware things like the web server, the database server, runtime data application and all the software which then actually runs on the underlying infrastructure, and all of it is your responsibility, you as organization running this on a premise data, and the center that is responsible for the whole lot. And let's start moving across this spectrum of a cloud models, and we will start with IaaS, infrastructure as a service. So now when you have a model and you only manage everything from the OS up, in the case of Azure, Microsoft Manager and everything beneath that, and again it doesn't matter whether it's a Zero or AWS or any of the other providers, the point is that in infrastructure as a service model that provides is doing the networking, the storage, the server, the virtualization, and you then get the logical bits, and that's it on the top of that. Now in some way, as a consumer of the service, this may not be actually look a bit different to when it's an on-premise data center. You still remote into machine and you have the operating system level control, so you can figure your middleware in your runtime and you deploy your apps. But what fundamentally changes is that there is no one left in the organization. So the consuming this service who can go and plug things into the server and change any physical configurations, like blinking lights on a machine. None of those things are possible because now the cloud provider is responsible for them. Now for some people they look it as a loss of control, yet on the other hand this is also a loss of responsibility, which means that someone else is taking care it for you. And as we progress through the course or through this lecture, the rest of the course will talk about more pros and cons about it. So for now though, let's move on the next model, and that's PaaS platform as a service, and it goes even further than IaaS because what's happening in a PaaS model is that the cloud provider is giving you, for an example, web hosting, where you have the ability to publish a web application, say onto the IaaS server. So as you get into the VR, you won't have the ability to interact directly with the things like the OS operating system, and you cannot install service packs and patches. So that is the cloud provides the responsibility. Same with the middleware. If it is the IaaS, you won't have the ability to interact, and with that you would middleware that's the running on all the infrastructure. As a service, you may still have the configurability by virtue of a application you deploy, or perhaps by virtue of their management portals. But as with IaaS, when I talk about the networking through virtualization, this is the something which not only do you longer access to, but you do no longer have the absolute responsibility for. That can be really good thing when it comes to the unburdening organization of this skill and resources required to manage the device and manage the services. So let's go all the way right through the SaaS. So once we get into the software as a service, there is really nothing left to manage. So think about the sort of software as a service that we might use on a very regular basis. So Salesforce Stop Claim is a canonical example of a software as a service. Not only you not managing any of the network or storage your server, you are not managing any of the middleware or a runtime either. You are not even managing the application. So not in the context of actual writing code, you are configuring the service such that it can be tailored to your organization. The cloud providers, again, such as Salesforce.com, is taking care of everything for you as you go through this paradigm from left to right. And as you can see them in the screen, the cloud providers takes more and more responsibility if you have less and less manage, and you get further and further away from the traditional model. So we refer back at the IaaS path and says we move through the lecture now, and let's move on something different.